This video is going to be an overview of the Picto data acquisition system. We're going to start by quickly going through all of the components of the system. Then we'll go back and try to build our own simple experiment just to get a sense of the way the state machine editor works for developing Picto designs. So let's jump right in. What I have here is a test experiment. This is actually the experiment that we're using in the manual that we develop throughout the Picto manual. And we'll start by looking at the test experiment window just to see what this experiment does. I go here and select the fixation task. That's the task that we develop as part of the manual. And I'll play it. And you see this task just creates a fixation point at the center of the screen. If the test subject fixates, then it presents a stimulus on the side. That ends the trial, and the trial starts again. This continues for 5 trials, and that ends the experiment. So this is the 3rd trial, and here comes the 4th, and I think this should be the 5th trial. And that ends the experiment. So that's what we have developed. Let's take a look at the state machine editor and get a sense for how this was designed. So here we're at the top level. This is the experiment level of the Picto design. And you see here 2 tasks. There's the eye calibration task and fixation task. If we double click on the fixation task, we can go inside and look at the code and the state machine that's being used to design it. So let's go inside. And you see here, this is the top level state machine. Every task starts with a state machine on the top level. Everything that happens inside the state machine is basically the design of that task. So let's double click there, go inside, and now you start to see a little bit more of what happens inside a Picto design. So each of these arrows represents control flow, sort of like a flow chart. Control starts at the green bar on the left side of the canvas. We call this the start bar. And it moves through the transitions into each particular element and follows the arrow. So in this case, we have a trial element. Inside this trial block is all of the code that we use for every single trial, the fixation point, the stimulus. As soon as the trial is done, that's the red result bar here, then we move over to this switch element. The switch element checks, is the task over, meaning have we completed all of the trials that we need? If it is over, then we go to task ended, and that's this result. And then we go up a level to here, task ended. That's the end of the top level state machine, and we're done with the task. But if we go back in here, if the task is not over, we get to no, then we go back to the trial and start the trial over again. So that's this level of the state machine. As you can see, it's pretty nicely self-documenting. You can really see the structure just based on the elements, the transitions, and there are some scripts involved here also that we'll go over in a minute, but I want to start with just the control flow for this project. So let's look inside the trial and see what's happening in there. So you see in the trial we have a few different blocks. This is a very simple task, but we start with the ITI, it's the inter-trial interval. We move from there to fixation, so that's the section where we fixate. The test subject is required to fixate on the central target. Then if they fail, we go back to the inter-trial interval. If they succeed, then we're done with that state. Move on to the next state, the stimulus state. That's the state where we show a stimulus on the right side of the screen. And when that's finished, then we go back here to done. We come back up 1 level, and now we're back here. So that's the control flow there. And now lastly, just to continue with the control flow, I want to look inside each one of these elements. So each of these is called a state. In Picto, the only place that time actually passes is inside a state. Everything else, the switches, all kinds of different elements, are considered to take 0 time. But as soon as control enters into a state, like this inter-trial interval here, then time can pass while we're inside this state. So in every state, there is what we call control elements. And in this case, we have a stopwatch controller. We called it timeout here. And what this element does is it just waits a certain amount of time. As soon as that amount of time has been reached, then the success result is triggered. We go to done, and we leave out here through this the end of the state. And basically inside here you can have multiple control elements if you want. Every frame they're checked, and until one of them triggers a result, the control continues inside the state, and all of the various stimuli that apply to this state continue to be presented. So that's this element here. Inside fixation, we have a different kind of control element. This is a fixation controller. In the fixation controller, we are checking to make sure that the test subject is fixating on the central target. As soon as they do, then the success result is triggered, going to this done result. And if they fail, if they wait too long, they don't fixate, and something's exceeded, they come inside the target and then they leave. Then we go to the failed result, and then they failed. So that's this element here. And stimulus, we have, in this case, we're not requiring the test subject to fixate on anything. We're just going to use a timeout, and after a certain amount of time, we finish and we go to done, and that's the end of the trial. So, like I said before, very simple, and that's basically the control flow for the entire experiment. That's what defined the control flow for the experiment we saw in the test experiment window. Now, there are a few other elements to the Picto design. The first that we can look at is are the variable elements. So if you look here at the top level, here we have a trial number variable. And this holds the number of the current trial. Like I said during the testing, this task includes 5 trials. So we use this trial number variable to store the number of trials that have passed. Inside here, inside the trial, we have a few more different variables. We have a fixate graphic target, or a fixate graphic, which is just a circle. We have a fixate target, which defines the region in which the test subject has to fixate in order to successfully complete the fixation stage. And we have a box, which is the stimulus that appears on the right side of the screen once the test subject successfully fixates on the fixation graphic. So those are these variables, and they hold various properties. If we go back up to the trial num, you see here it just has a value property. There's name, and then we have a value property here. If we look at the graphics, they have a lot more properties. So if we look in closely here, you can see we have a name. There's the UI enabled, which defines whether or not parameters will be exposed during the course of the experimental run for us to change. There's position, so that's the position of this graphic. 400, 300 says that it's, since the resolution is 800 by 600, that says that this graphic is going to be in the middle of the screen. The color in this case you can see is white. We have here also layer, which defines which graphics are in front of other graphics. There's visible, so if the graphic is going to be visible or not. Operator view and subject view define who actually sees the graphic when it is visible, the test subject or the operator, which is the researcher who's controlling the experiment. Outline will define whether we see the entire graphic or just an outline of that graphic. If we are using outline thickness says how thick the outline of the graphic will be, and then radius, in this case, this is a circle, so the radius defines the size of the circle. So those are the properties of this graphic, and every graphic has its own properties. So here we have a fixate target. It has similar properties to the fixate graphic since it's also a circular shape, and it's also something that shows up on screen. Here the box is a little bit different. Here in this case, size is defined by x and y, or width and height coordinates, but you see they're all basically the same. And the rule about variables in Picto is they have a certain scope. So if you take a function in most languages, if you define a variable inside the function, so that variable has scope inside that function, but once you leave the function, you can no longer access it. So we have scoping rules in Picto as well, and what they say are every variable on a particular level is visible by everything on that level, by the parent of that variable, and by everything beneath the levels. So basically, for example, if we take this here, this trial num variable, everything in the experiment can see this trial number variable. Everything inside trial could see it, and here we can see it because it's at the top of the tree here. But if we take this fixate graphic circle here, this variable, well, So the canvas that it's in, this trial, its parent can see it. All of these components here, the ITI, fixation, stimulus, these can all see it. But if we go back up here, the isTaskOver switch, this can't see the fixate graphic because it's not in scope for the isTaskOver element. So that's the way the scoping works. And with stimuli in particular, scoping defines whether or not the stimuli will be visible in a particular state. So if we take this circle, for example, this is the fixate circle. If this fixate circle is in scope for any state, then it will be displayed in that state so long as it's marked as visible. So in this case, these properties here define the initial condition. So the initial condition, when this fixate graphic enters scope, which means when control flow enters the trial element, the initial condition is that it's not visible. So that's why in the ITI we don't see it. But actually, we'll get to scripts in 1 second, but there's a script here which says fixate graphic.visible equals true. It's setting the visibility of the graphic to true. And once that happens, every state for which the fixate graphic is in scope will then see the fixate graphic. It'll be displayed in those states. So now that we've gone through that, let's go back up and let's take a look at scripting. That's sort of the last piece of the Picto design system, at least in terms of experiments. So here, within every start bar of every element, there is the possibility to have scripts. And so if you see here, this little blue area here, this represents a script. You see a little tooltip just popped up that said the script is trialnum.value++. And the way we set this script, and in general, the way we look at it is you'll click on the start bar. And when you do that, you see we have two scripts that are defined for this element. There's the entry script and the exit script. So the entry script is going to be called as soon as control flow enters the trial element, and the exit script is going to be called as soon as control flow exits the trial element. So in this case, as soon as we exit the trial element, we increment the trial number, trialnum.value++. So we increment the value property of the trial number. And then we come in here, and here this is the isTaskOver switch. So I said in most cases, or in almost all cases, scripts are defined within the green start bar, but in some few cases we put scripts inside an element itself when the script takes charge of the logic of that element. So the way a switch works is a switch needs to trigger a particular one of its results based on some sort of a logical condition. So we define the logical condition using a script. So if we look here at the property of the script property, the property of the switch. So we see here the script says if trialnum.value is greater than or equal to 5, return yes, otherwise return no. So now if we look back here closely at the switch, we have two results, yes or no. So we're saying if the trial number has passed 5, then we'll return the yes result, otherwise we'll return the no result. And that defines which direction we go. The yes result will finish the task, and the no result will bring us back to run another trial. So that's the idea of the script. Scripts are written in simple JavaScript. There are a lot of tutorials online that you can look at to understand the way JavaScript works. We're not using most of the complexities of JavaScript here. It's just for the simple accessing of variables and changing them. But let's go through a little bit more and look at some more scripts that we're using here. So if we go into the trial element, I talked about the fixate graphic. So I said that the properties that we have here define whether or not or what the initial condition is of the particular element. So we said here that the fixate graphic starts out invisible, but when we get to the fixation state, as soon as we start it, see here we have this fixate graphic.visible equals true. So as soon as we start this state, then we're setting the visibility of the fixate graphic to true. Now it's visible, and it'll last throughout the course of this state. Let's see here. There's another script here. It says box.visible equals true, right? So in this case, the initial condition of the box is that it's not visible. But as soon as we get to the stimulus state, We set the visibility to true, so now the box will be visible. And now, since we didn't turn off the fixation graphics visibility, when we're in the stimulation state or the stimulus state, we can see both the fixate graphic and the box. So that's what's happening there. And let's see, one of the last pieces here is the fixate target. So fixate targets are, they're a lot like regular graphics, but with some slight differences. So you can see by default here they're visible, and operator view is true, but subject view is false, because in general we don't want the subject to be able to see the region in which they're allowed to fixate. We just want them to fixate on the particular graphic. The window is sort of for us, for the operator. So these are the defaults. The default color is green. And the visibility is a little bit strange here. So I had said that graphics are always visible for anything for which they're in scope. So in the particular case of control targets, the graphics are actually only visible if they're being used within a control element, if something's looking to see whether or not the eye position is within that target. So if we go back into the fixation state and we look at the fixation controller, we see it has a lot of different properties here, but one of these properties is the control target property. So that's defining which control target are we using to decide whether or not the subject is successful in fixating on whatever they need to fixate on. So we've typed in there the name of that target, the fixate target, and the Picto code says that as soon as we start looking at that fixate target, as soon as this target controller starts checking it, then it's going to suddenly be visible, and as soon as we stop checking it, it won't be visible anymore. So throughout the course of this state, we're going to be able to see that green outline if we're in the operator view. So that's the way fixation targets work. Some other pieces here, let's see. Okay, so here's one more script we've added. And what we say here is, okay, well, what if the subject fails to fixate on the fixation target? So that means the failed result will be triggered. So in that case, if we're going back to the intertrial interval, we want the fixation graphic to disappear so that we have a blank screen for the intertrial interval. So what we're going to do is only in the case where the result is failed, we're going to turn the visibility of the fixate graphic off again. And that's what you see here inside. So the results has one script. Results only have an entry script since they don't contain any internal logic. Otherwise, they only really need one script. So inside the entry script, we have fixate graphic.visible equals false. And that looks to me like that's the last script that we're using inside this level of the state machine. So that's pretty much it. Another point you can see here that this canvas we're looking at represents the trial element, and this green bar on the left side represents its start bar. We can also actually click here on this canvas start bar and see the same script that we see on the level above. So that's the same script that we see right here. And another thing that's really good to pay attention to, this is really crucial. Obviously, I'm moving a little bit quickly, and there will definitely be a lot of questions even after people read the manual. But one of the best sources of documentation is down here in this tabbed view, this About Element tab. This is sort of contextual in-application documentation. And anything you click on, the documentation for that element is going to appear here in this area. So if I click on this switch, for example, now we have switch here. There's an overview of what the switch does. This is a description of all of the properties that we see over here. So we have the analysis, entry, and well, we'll get to analysis in a minute. But there's entry scripts and exit scripts, which are what we see when we click here. And then we have name and script, and that's what we see here, name and script. And then we also have things like script functions. So these are the things we can use if we're in our scripts if we want to access data from different elements of the state machine. So here's where these things are documented. So if we look, for example, at the trial num, we see the trial num has a script property of value. It says it sets and gets the current value of the variable. So that is actually what we were using in the script, in the exit script of trial. We said trial num.value++. So that value is the script property that we were talking about in the About Element box. And that's incredibly useful. You can also use it here with the element library. So if we go in here to variables, there's all different variables we can use. Here's a variable list, and you can see here's all the script functions we can use. This one doesn't have any script properties. It has regular properties that would appear in the property browser on the right side. But if we look here, say it's stimulus elements, here we have a circle. Here, these are the regular initial condition properties. Here's some script properties, colors, visibility that you can use. Here's some functions that we can use to set all the colors at once. So this About Element tab is incredibly useful. The Scripting Info tab is also somewhat useful. It says if we're looking at a, let me turn this off. If we're looking at a script or an area where we can write a script, then this is going to tell us what all the in-scope variables are that we can use from that script. So that's somewhat useful. And then this other tab here is grayed out right now, and the reason for that is that has to do with compilation. So once we've finished an experiment, finished designing our experiment, we can click here, check the current experiment's XML code for syntax errors. We click here, and then the error list pops up. If we don't have any errors, then we'll have syntax check passed, and that tells us that we're good, we're ready to run the experiment. So maybe we'll do that again, come back here, and let's go ahead and run it again. And so you see here, that was our inner trial interval. Now we're showing the fixate graphic. Now the control target that we looked at is deciding that I'm not fixating because my mouse pointer is outside of the fixation window, the fixate target. So we keep on moving through the transition back to the ITI again. But as soon as I go inside for a second, it's going to decide, oh, I succeeded. It'll show the stimulus and then finish the trial. So that's what's happening here. One more piece that we didn't talk about last time is this parameter region over here. So if you remember, when I talked about the fixate graphic, when I went through the properties, one of them was UI enabled. And let's look back at that right now. It's a real simple little property right here, UI enabled, and we set it equal to true. Okay, so what that does is it says that all of the properties here that would make sense that we might want to change them at runtime are going to show up in the parameter window over here. So you see we can change the position, the color of the target, the layer, visibility during the course of the experiment. Now, of course, we don't want to be able to change it at just any point within control flow, because if we do that, we have no idea. We could be between two different scripts that are going to it'll create some kind of an error condition. So what the idea here is that when we change a value here, what it does is it changes the initial condition. It changes that proper that we saw on the right side. And so what happens is every time those initial conditions are reset, which means every time, in this case, every time we enter, control flow enters into the trial element. So then whatever we set here will be copied over and used as the run value. So for example, if we change the color here, let's change it to this nice orange color. So you see here, the color of the target is still white. And what it's going to take for the color to actually change to orange is to leave the trial element and then come back in so that the trial element re-enters, so that the fixate graphic re-enters scope within the trial element. So let's do that. We'll finish the trial, start it again, and there it is, orange. And we can do the same thing for position. Say we make it 600, 300, and nothing's going to happen yet. Right, but here, if we then finish the trial and start the trial again, lo and behold, the graphic moves over. Now, we've only changed the fixate graphic. We haven't moved the fixate target window, so that's going to stay in the same place. But you get the idea. So that's it. That's how we create experiments. It's how we run them. I'm going to go quickly over the analysis now. So for analysis, the idea in Picto of analysis is that we layer a new element on top of the experimental design. So here we see our experimental design. Here's sort of the top level of the experimental design within the top state machine. And if we go up here, this is the sort of select analysis region. And we have here, this lets us create analysis, this lets us choose between our analyses. Currently we're not looking at any analyses. This plus lets us create a new analysis, and then once we've got an analysis selected, this will turn red, and we'll be able to delete it there. So we've already created an analysis. This is the one that we create as part of the Picto user manual. So let's go to that, test analysis. And now you see a lot of things just happened. All the elements that we used to design the experiment were just grayed out. And now there's a few new elements here. These are these analysis elements. So we have a couple of analysis elements here. This is an out file. So this represents an output file. And if we look at about element, you'll see it has some script functions that we can use to write a line of text. For example, write text, write a line of text. There's also the capability to write a binary file, so we can use those. This is some signal data. We're using this to get the position data about the signal. And we're using this to get the information about the position signal. And so this has a lot of scripts that we can use also. So get the next time that the position will be read, for example. Let's look more closely. Get the next value that will occur, next position value will occur, get the previous times at which the position signal was read over a certain number of seconds preceding the current time. There's also get latest value up here, which returns the latest value of all the components as a JavaScript array, X, Y values. So these are all things we can use during the course of analysis. And then the question is, okay, now we have these variables, how do we actually use them? So the way we use them is with scripts. And if you look here, we used to have just a little blue script here, and now we have this yellow one in addition. So that the yellow always indicates analysis and blue always indicates experiment. So let's take a look at that analysis script. So what we do in this analysis script is we say outFile.WriteLine, and then we're writing some data here, trialNum.value. So the analysis scripts have access to all of the experimental elements. So we take the trial number, the current trial number, then we add a comma, and then we add outputLine.value. So we'll see what outputLine is in a minute. That's inside trial. But once a trial, we're writing that to our output file. Now let's go inside trial. We'll take a look at this output line. So here's the output line variable that we were talking about. And what we're doing in here is we're adding some data to that. So I can see here there's only one yellow script anywhere here, so this must be doing the work. I'll click on that and we'll look more closely. So we're saying outputLine.value equals fixateGraphic.color. So we're taking the color, the current color of the fixate graphic, and then we're adding to that another line with a comma with the position signal.getLatestValue. So JavaScript very nicely takes its arrays and automatically turns them into comma-separated strings. So this is just going to return, first we have the color that we did in the first line, and then down here we're going to have the just the X, Y position comma-separated of at the time that this script is called. So that'll be when the stimulus state ends. So every trial, once a trial, when we get here, that's written to this output line string variable. Then, as soon as we leave the trial state, the trial element, we then take that data, we append or we prepend the trial number, and we write it to the output file. So that is our analysis. And if we go here to the test experiment, you see here we can select the analysis. We'll say, okay, we want to select this test analysis. Now we're going to start the fixation task, and we'll run it for a few frames. Let's see. Here we'll just do one or two regular frames here. Now let's try changing the color, because we were going to look at that. So we'll change it like this, make it whatever that is, magenta. And let's finish this up. I'll put my mouse over here so that it's at a strange place at the end of the trial. And now you see the color has changed. So let's just finish out the trial, or finish out the task. And good, now we're done. So now that we're done, we can go to the analysis output tab over here. And now let's take a look. This is our analysis output. You see, for the first 3 trials, the color was white. This is a hexadecimal code for the color. basically every two numbers represent a color, red, green, blue. So FF is the highest possible value in hexadecimal. 0, 0 is the lowest. So here we have red, 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 and then this was the magenta with no green component, but some red and a lot of red and a little bit of blue. If we look here, these are the XY positions. So I remember on that third trial, I moved the mouse all the way to the right. So you see suddenly it jumped to 759. And these are our output values. So that's how we test the analysis. And then if we want to save it, we can just hit the save button here and just put it wherever we want to put it. And it's going to be named like this. This automatic names based on the task name, the time at which we started the task, and the suffixes that we put as properties inside the output file, or the file output element. So I'm just going to cancel out here, but that's the idea of analysis. So that's pretty much it in terms of sort of a broad overview of the design. When we want to actually run the experiment, we go over here. We select a director. The director is the machine. It's a dedicated machine that runs the experiment for a test subject. And what we're doing here is we're just loading our experiment onto that machine, and then we can send it commands, and then it does all the work. So we have to give it some sort of a key. This is just used to make sure nobody else who's looking in on our session can accidentally change values. And now we're going to start the session. We'll join to it, and since it doesn't exist yet, it'll be created. And we'll go here, we'll select our fixation task, and now this is running on in theory it's running on a different computer. In practice, for the purpose of this tutorial, it's actually running in a window behind the current one that we're looking at. So we start it, and in a second it'll get started, and you see my mouse is actually controlling it right now, and so we can run this task here. And we're just running it right like usual. I can do the same things we did here. I'll change the color. This time maybe we'll make it whatever that is, reddish brown, say. And we run this task. Maybe this time on the fourth trial, I'll move my mouse all the way over here. And then we'll finish up the fifth trial. And there we go. That will be the run of this task. Another thing you can use here you can provide rewards by pressing this reward button. That just sort of gives out-of-band rewards to the test subject. You can zoom in and out of the window here. That's useful for calibration, which I'm not going to go into in this video, but there's some detail on that inside in the manual. Here we have the run info windows. This is useful. This is going to list, when we click this, it lists all the task runs that we performed during the course of this session. In this case, there's only one. If I go down here to the modify button, now I can change it. So let's say I can change the name. Maybe instead of fixation task, I'll call it my fixation task. I'll give it some notes. Here are some notes. And here, this button lets me switch between saved and unsaved. So let's say I like this task. It had useful data, this particular run, so I'm going to save it. And now I'll apply. And now you see my fixation task, everything here is saved. And if you have multiple workstations viewing the same experiment, the same session at the same time, these notes are going to automatically be propagated to all the workstations. Everything is sort of cloud synchronized, you might say. So that's that. And now let's finish up the session. To finish a session, to end it, we just stop the task. In this case, it's already stopped. We disconnect, and now we could just disconnect and leave it running so somebody else could take over. But here it's asking us, do we want to disconnect from a session since it's not currently running? And we'll say yes, and that'll end the session. So now the last thing that we want to do here is we're going to go to the replay experiment window. And that's going to let us both playback and analyze our experiment at the same time. And the idea here is that what we're playing back here is not just video of what happened in the session, but it's actually both video. It's not video at all. It's actually running through the state machine that we created, running through all the properties and all the state machine transitions and running back through that state machine so that it can call those analysis scripts as soon as they need to be called. So what we can do is we can play the session back, and if we select an analysis, then just like we saw in the test experiment window, it'll just analyze during the course of playback. So let's give that a try now. Here we're going to open up the session that we just recorded. session is always it's always in the sessions directory of the Picto server underneath the name of the director and the name of the experiment. So this is the one we just recorded. Let's open it up. And now you see here we have this, this is the sort of select runs window. So what's going to show up here is all the runs for this particular session that we opened. You can also open lots of sessions and it'll show all the runs for all the sessions here. We just did this one. So we're going to start there. We can just click it here. We can also do select save to select that. And let's start by just playing it back. So we'll play. It always takes a few seconds at the beginning for the load time. And then what we'll see is we'll see it playing back exactly what we did during the course of the session. So yeah, here it goes. You see there's our little crosshairs, exactly what we were doing. And one really useful feature for the playback here is, well, let's see, there's a lot of things you can do. You can slow down. Let's slow down the speed. So now you see things are moving pretty slowly. Maybe we'll move it up to 0.5. And now things are going a little bit faster. You can also jump around. Let's say we want to move back here. So now it's moved back to the previous position. We can jump forward, fast forward up to where we decided to go. You can pause, which is just gonna stop where we are, and then you can maybe you can move around, say move back over here, and then resume. So these are the types of things you can do. And let's see, another useful feature, see, when you're playing it back, you can switch between operator and test subject view. So let's imagine that we're the test subject now, and we'll be able to see exactly what the test subject saw, not what we were seeing in the operator view. So let's see, let's take a look when it finishes the load process. So here, this is what the test subject views. You notice they don't see the green window outline that we see. So that's one significant difference. And everything's twice as long here since we're running at 0.5 speed. But so here you see they don't see that outline. Another really useful feature for presentations is you can press this toggle recording button. You see now this is the record time that's moving forward, and it's just recording exactly what we see on the screen. So if we move back up to real time, then it's going to start speeding things back up again. And say that's it, we're done, that's what we want to record. All right, let's take that and just pause this for now, and we'll save out our video. Let's just put it on the desktop here. We'll call this test experiment. We'll save it. And now, actually, if we want to get out of here, if we want to look at that video, hopefully this will work with the screen capture application with Windows 8. And you see here that it's just playing back what we recorded inside from inside the playback viewer there. So yeah, that's and this is very useful. This is just an AVI file, so you can embed it in a PowerPoint presentation. Let's get back to our playback system here. So now, say we played this back, very nice. Now we want to analyze it. So all we have to do is we go over here to our Select Analysis tab. Let's just stop this, go here, and now we see here there's two tabs here. There's Session. So these are the analyses that we saved with the session, and there's also the import capability here. This is actually incredibly useful. The idea here is, imagine that you created a session. Maybe you didn't save any analysis design with it, or maybe you did, but you didn't think of something that you realized later on that you should have pulled out, that you should have analyzed. So what you can do is you can actually import a new analysis into the existing session and run that analysis on the session. So that's very useful. In this case, we'll just use the local session analysis that we saved. And all you have to do is you just play it back with that selected. And it'll just run back. We can actually just move this to the end so it'll speed to the end. And if you look here, here's the analysis output. You see here where the color changed, so the red just got a little bit darker. I guess it was just dark red, not red-brown like I said. You see here where the X position of the mouse went way up, like I was demonstrating. And just like in the test experiment viewer, you can save out your results here. In a real experiment, this is going to be complicated, you know, with lots of columns, something that you want to analyze in MATLAB. So you'll do that. But this is where you're going to save it out. So that's pretty much it. That's start to finish. You design an experiment, test it, run it for the test subject, and then analyze it. And now, so let's quickly, maybe we'll run through our own little development of a quick task, just because it's always different to see one that's already built and analyze it, and then just to make it yourself. So let's click here. The experiment's been modified. Do you want to save changes? We'll just say no, because this is just a test experiment anyway. And so here we are now. We're starting from scratch. Every experiment that starts from scratch starts with an eye calibration task. Like I said, I'm not going to get into that, but you always have to calibrate the eye position of the test subject. So we always want to have that as one of our task options. But here, let's add a new task here. And we'll call this just say test task. And why don't we make this task, we'll make it similar to the task that we just had, but say in this case, instead of one little stimulus, in fact, why don't we'll cut out the fixation graphic altogether, and we'll just have a choice of two different graphics that the monkey can fixate on, the test subject can fixate on. And in general, you're always going to want to have a fixation graphic, but for our purposes, you know, this is just to demonstrate the way things work. So let's go in here. We have our top level state machine. We'll give that a name, top. Now let's go inside, and let's start adding some components. So we'll put in here a sub state machine, which is, we'll call this our trial, right? Just like we did in the other task. Then just like in the other task, let's have another switch that checks to see whether or not we're done. So we'll say is task done. Just like last time, we'll add in a number variable that we can use to check. We'll call that trial num. And as you can see, a lot of different tasks are going to be built in very similar ways, because most tasks use a certain trial structure. They don't all use a trial structure, and this that's one of the ideas behind this development system that doesn't require you to use a trial structure, so you don't have to use this sort of this top level that we're using right now, but you can, and so that's nice. So now we have our trial, we have our is task done, nothing has any results. So let's go in here. Oh, looks like I spelled is task done wrong. Let's go inside here and let's add some results. So like we had before, we'll have 2 results. All right, and we'll call the first one, let's just do lowercase. Or not, yeah, I usually I like to start things with uppercase if they're part of control flow. So yes and no. So here we have the yes and no results. Inside the trial, let's add a result, which is the done. And maybe this time, instead of just a done, we'll say we'll have a failed result also. Failed. So now we have done and failed. And then let's have a result to finish the task. We'll say done. And now let's just wire everything up. So let's go from the start bar, wire it over to this trial, start the trial. If the trial is done, we go here, is task done. If it is done, yes, we go to done. If it's not done, we go back here to the trial again. And let's say if the trial failed, well, we'll just start it over again. So let's do that. Okay, and just like we saw last time, let's add a little script here, and we'll say as soon as the trial ends, well, let's see, last time we put it here, we said if the trial ends here, then let's increment the trial number. But in this case, the trial might fail. So instead of putting it there, we'll put it in done. If we reach done and not failed, then we say trial num dot value plus plus. And that's going to increment the trial number. And then we'll put in the script here saying if trial num dot value is greater than or equal to, let's just make it short this time, 3. Then return yes, and this is just the name of the result that we want to trigger. And if it doesn't return yes, then it's going to return no. So that's going to be this switch. And one point to mention here is that we like to make sure that all of our scripts that can actually change values are inside start bar. So it just improves readability. So if I were to put any kind of code in here that would change a value, for example, if I said trial num.value plus plus here is greater than or equal to 3, so that would increment the trial num value and then check if it's equal to 3. Or I guess it would do that. I would check it first, then increment it. But regardless, if it increments it, that's considered an error. And during the testing and the test experiment window, that's going to actually trigger a runtime error. And it's going to say you're not allowed to change a value from inside a switch script, only from the start bar scripts. So that's an important point to remember. So in any case, let's go in. We have to fill out our trial elements logic. So let's go in here. And now let's see, what do we want to do? So we usually like to start with an ITI, inter trial interval. And let's just go ahead and fill it up right now. The inter trial interval, we'll use a stopwatch controller. We'll just call it timeout. And we'll give it, say, a 2-second inter trial interval. This is turning out to be very similar to the task that we were working on before, but I guess that's just what I'm thinking about right now. In any case, here we have a success. If you have success, then you're done. Wire it up, and then we've pretty much finished our the inner trial interval state. Now let's move on to the next state. This is going to be the choice state, so we'll call it choice, and this will allow the test subject to decide which of the elements they want to look at. So let's go down here and let's take a look. Let's say we want to add ourselves some stimulus elements, which will be, say, 2 circles. We'll have a left circle, and in fact, let's just work on the left circle, and then we can copy and paste it. So we'll call this left graphic, and we'll give it a position of, say, 200, 300, so it'll be on the left side of the screen in the middle. Let's make it whatever that color is. And we'll make it visible to everybody, but actually no, we want it to start out invisible, right? Because we don't want it to be visible for the inner trial interval. And of course, there's other ways to do this. We could put this whole thing inside its own sub-state machine, but in the interest of time, we're just not going to do that right now. But anyway, so here we have our left graphic. Let's give it a radius of, say, 40 pixels, which is actually probably a little big, but that's fine. And now let's just copy and paste it. Just copy, paste, and now here we have the left graphic again. Let's call it right graphic. Let's change the color to something else, because maybe we're trying to decide if the monkey likes one color more than the other. Okay, so that's our right graphic, and then everything else will stay the same. And now, since we want to check if the monkey is actually fixating, we want to create targets, so control targets. So let's put one here, and we'll call this left target, and let's give it a radius of a little bit bigger than the other one. Let's say maybe 60, so it's a little bit of a bigger radius than just the circle itself. And let's put it at the same position as the circles. That's 200, 300. So that's good. Let's just copy and paste it, and we'll make a right target. Right target, let's give its position 400, 300, and everything else can stay the same. So that's good. Now let's go inside the choice state. And inside the choice state, we're going to use a new kind of a controller, the choice controller. So here we have our choice controller. Let's just call this check choice, right? And it's checking the position signal channel, so that default is good. It's saying they have a total of 5 seconds to fixate, but they need to fixate for 1 second. Well, let's tighten that up and let's make it 2 seconds total time. And now the way this works is we add a result, what we call control target result. So we're now inside the check choice. I like to capitalize that first letter. So now we're inside the check choice controller. So we go in here, we add a control target result for every control target option that we want to provide. So now let's say this will be the left choice, and the control target that it's going to use is the left target. And this will be the right choice, and it's going to use the right target. So that's good. Let's come back out, and now we have our 4 pieces up. Keep on breaking my own rule. I'm using lowercase letters here. I think it's useful to use lowercase letters for variables and uppercase letters for elements of control flow, just to keep things clean, but obviously that's not a requirement. In any case, here we're going to have, let's say, here we'll have left choice. Here we'll have right choice. And here we'll have failed. And let's wire things up. Left goes to left choice. Right goes to right choice, and if total time is exceeded or broke fixation, then it failed. So now that's wired up. That should be ready, and now we have all of these 3 results here. So let's move this all down a little bit. The left choice now is going to go to done, right choice will go to done, and failed will go to failed. The ITI, when it finishes, it goes to choice, and here the start bar goes to the ITI. Now let's see, what are the other elements here? We said we had to set left and right graphic visible. So let's do that here. And the entry script of choice will say left graphic dot visible equals true. And then it's just copy and paste that. And we'll do the same for right graphic. Right graphic dot visible true. And actually, one thing I didn't use in the previous experiment that I probably should use, in fact, 2 things, were a reward and a pause point. Pause point is the place at which the experiment pauses when you press pause. It doesn't just pause during the course of an actual experimental run. When you press the pause button, it actually continues running until you reach one of these pause points. And also, of course, if we're running an experiment, then the test subject's probably not going to work unless we give them a reward. So let's get rid of this stuff here. We'll just delete that. We'll put in a reward here. We'll just call it reward. Reward quantity is 60 milliseconds of reward, and we have 1 reward, and then we'll just say either one, left or right choice, you'll get a reward either way. And then you're done, you go here. And for the pause point, why don't we just put that right before the intertrial interval. So maybe we can move this all over a little bit. And move this over here. We'll call this pause, and get rid of that, and we'll wire up pause before the ITI. And that way, if somebody presses pause, it'll just pause as soon as it gets back to that position. So that should be about it. I'm not going to go through building an analysis here, just in the interest of keeping this somewhat short. But if you did want to do that, you'd add analysis here. Then you see you have this not yet named. Let's give it a name of analysis, say. And then you can add, here we had the file output object in the other one. So here it is with the file suffix. Here's the various sensors that you can use. To find out about all of these, you just go down here and read the about element area. But I'm not interested in using that right now, so we're just going to get rid of it. You sure you want to delete the analysis? Yes, I do. And that'll be about it. So now let's check, see if we have any errors. It says syntax check passed, and that's a good sign. There is still the possibility of runtime errors. JavaScript is very good at allowing things to have correct syntax, even though they actually will cause things to break. So you never really know for sure, but that's a good indication. If there are runtime errors, we'll see them here. So let's run the task and see what happens. Okay, so something funny is going on. Obviously, there's some error. You see here, this is one of the control targets. This is the other, and what it looks to me like is happening is one of the colors is on top of the other, so it could be that we didn't properly enter that. One of the graphics is on top of the other. So let's go back over there. Let's check that out. Go back in here to trial. So we have the left graphic is at 200, 300. Right graphic up also 200, 300. So let's make that, let's see, it's supposed to be, from 200, 300, let's make it 600, 300. Okay. So that's good. And then this here, we made it 400, 300. It should be 600, 300. 400, 300 is the middle of the screen. And yeah, so that's good. We never actually saved this. That would be a good idea. So let's just save it now. Desktop, say, test experiment. No, we already have that. Let's call this new test experiment. Good to have it saved. And yeah, let's try it again. And there we go. We have the two different targets appearing. If I don't fixate, they just disappear. If I do fixate, then you hear that click. Hopefully you could hear that too, and that click indicates that a reward was supplied. So that's it. Twice there, say we'll go once here, and that's going to be the end of the task. Just a few quick points. We can add, we can make things parameters here, just like we did in the other case. So say we here set UI enabled on the right graphic. All right, let's save that. We'll go over here and we'll run it. Now you see here, right graphic. Here's the color, and we can change it to whatever we want. And now next time we enter, it's changed. So that's good. And let's see, one last point that I didn't mention previously, but this is also extremely useful, is the search bars here. So if we search here, say we search for ITI, it's going to highlight everything in the screen that matches ITI. So let's see. Here you see the ITI is highlighted. Now what about everything that uses left graphic? Okay, so we want to see what's changing values in left graphic. Well, here's something. This script's been highlighted. Let's take a look. Click here, and now it's highlighted left graphic. So the search is actually very useful. You can also make sure that the case is matched, upper or lower case, and that turns out to be an incredibly useful thing, especially for large experiments that other people wrote to help you start to understand what exactly they were doing. So that's very useful, and yeah, that's more or less covers most of what you want to do here in Picto. I'm sure there are a few things that I've left out, but obviously you can read the manual for that. Yeah, but that's the process. So we've gone through. In the first case, we looked at the previous test experiment. We tried it out. We ran it on a remote machine. We replayed it and analyzed it. And now we've gone through the process of building our own experiment. So that should be about it. And if you have more questions, don't forget the About element box. That's incredibly useful. So you can always go in there and check that out. And don't forget the manual, because the manual is obviously a great place to go with questions.